Topic 5D, let's talk about weather systems. So we've talked about the weather variables. We've looked briefly at how to read the station models, which will come up later on. And so now we're going to put the pieces together and hopefully start to make sense of this in a practical way. So if you're watching a weather forecast or the Weather Channel, that kind of thing, um, you'll be able to see if they're right or not. You're by no means going to be a professional meteorologist, but the reality is sometimes forecasts say things for a general area, and where you are specifically, you might be able to tell otherwise. And that's our goal. So we will go through types of air masses today and types of pressure systems today. We'll save fronts for the next video because it starts to get pretty long at that point. So first of all, the picture is just kind of neat there. We have some water spouts. Lake Ontario actually does get water spouts. If you live near the water, if you're on Pillar Point especially, you could, in all reality, see these things, these water spouts. Happens on warm, sunny days usually, when warm air is rising off the surface of the lake. They're generally not dangerous. They look like tornadoes for all the world, so they'll make you a little nervous, but they're generally not dangerous unless you're on a really small craft. Then you might get tipped over. So, but they don't have the 300-mile-an-hour winds of tornadoes. They just look really impressive. All right, so you'll hear the term air mass all the time. I'm going to use that term like it's water. It's just going to be flowing all over the place. So, an air mass just means a chunk of air. So you don't think of air as terribly chunky. You're not going to be walking around and bump into a chunk of air and fall over. But air in the atmosphere does group up. It does tend to be big lumps that all have the same property throughout it. So an air mass is just a big chunk of air that moves across the Earth's surface together. It has similar characteristics throughout it. The two characteristics we worry about in here are temperature and moisture level. It's either going to be warmer or colder than the air around it, and it's going to be either really wet or really dry or somewhere in the middle. But those are the characteristics that we need to worry about, temperature and moisture level. Now, it is totally logical. I know I don't get to do that all the time in earth science. Not everything seems logical, but it's totally logical where they pick up these temperature and moisture characteristics. If you have an air mass that sits around over cold land for a long time, nothing pushes it out, it just kind of sits there, it's going to pick up the characteristics of the land around it. So if it's over cold land, it's going to be cold air. If it's over the ocean, it's probably going to get wet because I don't know if you've noticed this, kids, but water is wet. So it's going to pick up the properties of the Earth's surface that are around it. So the region it comes from is called its source region or region of geographic origin in questions. So it sounds really fancy, but it's just saying where it came from. Now, it's hard to have one map that's going to do this right, but here's my best one I could find easily. So you're going to end up with, like for us specifically, we have cold, dry air that comes down out of Canada, especially this time of year. It comes down out of Canada a lot. And so when air comes down out of Canada, you expect it to be cold and dry. Today's what, Tuesday? You're watching this on Wednesday. There's a nor'easter going through, so it snowed pretty much all day because warmer, wetter air has come up from the south along the east coast of the U.S. and it's brought some moisture, a little bit warmer temperatures today. So it all depends where it comes from. Those are the source regions. So typically for us, being northern hemisphere occupants, cold air comes from the north, warmer air comes from the south. That's what we would normally expect. So there's four different, maybe four normal possibilities you're going to run into in earth science. And we might throw another one in there just because it is in the reference tables. But the air masses are used using a pair of letters. The first letter always indicates the moisture level. The second one always indicates the temperature. Now, it's just the format they're always in. The first letter is always lowercase. The second letter is always uppercase. Just the format they chose. So if you have a lowercase c, it stands for continental. you know what the continents are, the big chunks of land on the Earth's surface. So continental air masses form over land, and as a result, land is dry, so they tend to have dry characteristics, not a lot of precipitation resulting from it. Lowercase m stands for maritime. Maritime means to do with the water. There's maritime museums and things that have to do with ships and whatnot. So maritime means it formed over the ocean, and it's going to be moist. It's going to be wet. It's going to have a lot of water present. Now, the second letter could be a capital T for tropical. Tropical means forming closer to the tropics. It's going to be warm. So if it forms at low latitudes and it has warm characteristics, it's tropical. And if you have an uppercase P, that stands for polar, meaning it formed near the poles where it's cold. So it tends to have cool temperatures for the season because it formed at high latitudes. Now, there is another one mentioned on page 13 in your reference tables. It also mentions A for Arctic, and that just means even colder. It's like super cold and dry. So if you see that, it's there. And these letters are all on page 13 in the reference tables. They do make sense, so I think they're pretty easy to commit to memory. But if you forget them, page 13, right below where the station models are that we were just working with, you'll find these symbols or these codes. All right, so where do they come from for us? Continental polar air masses, typically for us here in northern New York, are going to come from central Canada, by Alaska, the Yukon, and dip down across the country or perhaps across us. So continental polar is going to come down like so. Maritime polar is going to form if we get it. We don't generally get these, but maritime polar could form way off in the Gulf of Alaska off the west coast and work its way across the country. But honestly, by the time they get to us on the other side of the continent, they're not very maritime anymore. So we don't really get influenced by those. If you move out to California, Washington, Oregon, the West Coast, then those are going to be a huge player and you're going to care a lot more about maritime polar conditions. Continental tropical is typically a summertime thing if you have an air mass that forms over the desert southwest and works its way up across the country. It's going to bring warm, dry conditions. And again, this time of year, we don't get a lot of that, just the way the air masses are flowing across the continent. In maritime tropical, maritime wet, tropical warm. Maritime tropical for us would start maybe in the Gulf of Mexico or off the coast of Florida, and then work its way up the East Coast, bringing warm temperatures and a lot of moisture. In the wintertime, maritime tropical can lead to nor'easters and heavy snowstorms potentially, or it might just be a above average temperature and kind of rain when you wouldn't expect it in the winter. Summertime, lots of thunderstorms and heavy precipitation. All right, so those are your four options that are really common. Now, one thing they all have in common, or large part do, is they end up going across us. That's one of the reasons we in New York State tend to get a little bit of everything. We're in the crossroads. All the different ones go across where we are, and as a result, we have some rather interesting weather. Now, the picture that just popped up is a wonderful hurricane. Well, wonderful if you're looking at it from a satellite view, horrible if you're living through it. Hurricanes are like the most maritime tropical weather system in existence. Tons of moisture, high winds, warm temperatures. They have to form over warm ocean waters. This past year was a record year for the number of hurricanes. As the oceans get warmer, we may see more and more of that. So just kind of a cool satellite view of that. So when an air mass moves through an area, weather conditions change. We just went through this, honestly. It's been cold for the last week, and that's because we had cold, fairly dry conditions. We didn't get much snow. And then last night it started to warm up, and today the temperatures are substantially warmer. I mean, it's still not summertime out there, but a warmer air mass moved in with more moisture in it. And as a result, we've seen a change in the temperature and humidity level in the atmosphere. Now, when they move through, that's what you're going to see. Change in temperature, change in pressure, change in dew point. Now, as these systems move, they don't just go in a straight line across the country. They spin. We've talked about the Coriolis effect before, the fact that the Earth is rotating on its axis. Things trying to go from the poles down to the equator, the Earth spins underneath them. So that's the Coriolis effect. Objects appear to curve when they're in motion across the Earth's surface, but not connected to it. These air masses are no exception. So hopefully you remember the Coriolis effect. We talked about it when we were doing Foucault's pendulum and evidence of the Earth's rotation. So in the northern hemisphere, everything wants to curve right. So you got two options for pressure systems. You have high pressure systems and low pressure systems. On a weather map, typically high pressure systems are going to be a big red H. It's also called an anticyclone, opposite of cyclone. In a high pressure system, the highest pressure is in the middle. Winds always want to go from high pressure to lower pressure. So since the highest pressure is in the middle, the winds are going to start in the middle and then head out away from that point. As they go out, they're going to curve to the right, their right. So that means in our hemisphere that the winds are going to be going clockwise and they're going to go outward. Now, in a normal year, when you were in the classroom, I'd be like, hey, where's the clock on the wall? And everybody points, it's high on the wall over there. Highs go clockwise. Why do you normally look at the clock in a class? Because you want to get out of the class. So highs are clockwise and outward, just the mental way of remembering that. Now, science speak, it all makes sense for why this happens. Winds start to go out from the middle, like the illustration is showing here. As they go out, they curve to their right. They keep going out further from the middle because away from the high pressure, they curve more to their right. And as that continues, they end up going around the high pressure system in a clockwise and outward motion. Now, high pressure systems, all things being equal, if you see a big red H on the weather map coming towards you, high pressure is typically good weather. It might be kind of cool for the season, which in the wintertime you don't want it to be cooler, but it's a little cool for the season. The more important aspect of this for the good weather side is it's probably going to be clear, sunny, and dry. You're not going to get precipitation. So that's typical for a high pressure system. Now, a low pressure system is the opposite. So if you know one, the other one's the opposite. So a low pressure is also called a cyclone. Cyclone is a term that's used in a lot of different ways in meteorology. In the Pacific Ocean, if there's we call it a hurricane, they call it a cyclone. Some people refer to tornadoes as cyclones, not so much around here. But it's just a low pressure system. So they're not wrong. Hurricanes are low pressure systems. Tornadoes are very low, like the lowest pressure on Earth. That's why they're so windy. So anyways, I'm rambling. The low pressure system, blue L typically on a map, that's a cyclone. In a low pressure system, the wind's trying to go into where it's lower. And so as it goes in, you actually have a couple of forces here. You have the pressure gradient trying to pull it in, and then you have the Coriolis force trying to curve it to the right, which they can sometimes like fight with each other. The stronger force here, though, is the pressure gradient. So that's what this very arrowy diagram is trying to show you. The winds try to go to the middle. Coriolis tries to pull them to the right, but it's weaker than the pressure gradient, so it ends up spiraling in. Like a water going down a drain, you get that swirly pattern. The hurricane that was a few slides back, that is an example, a very visible example of a nice low pressure system because you can actually see the winds, the cloud formations going counterclockwise around it and in toward the low. Now, low pressure is typically not what you want to have coming towards you on the weather map. Low pressure usually means unpleasant conditions. Probably windy, maybe thunderstorms or snow squalls, like the equivalent of a thunderstorm in the winter. The nor'easter that's going through presently, you have a counterclockwise rotation around the low as it goes up the east coast. It brings moisture with it, and it runs into colder air to the north, and we end up getting snow. That's kind of typically what happens in the winter. So conditions are warm for the season, perhaps. I mean, not like, oh my God, it's so hot, but warmish. It's going to be damp. It's going to be overcast. You're not going to see the sun. All right. So that's the highlights for today. So we should know about air masses, what source region is, the four types of air masses: continental polar, continental tropical, maritime polar, maritime tropical. A high pressure system, you need to know which way they rotate and whether it's good or bad weather, what kind of conditions you would expect, and a low pressure system. So that's what we hopefully got out of today, and that's what you're going to see on the worksheet. So thanks for watching.